Morning, happy Friday again. Today we're going to talk about RAG API on Google Cloud, and I advertise this as 30 lines of code is all you need for RAG. So let's see if this is actually true, and let's see how good this API is. I think Google Cloud's RAG API is one of those less known offerings, but it's actually super fast and easy to get started to build a RAG application with the RAG API. It's built on top of Llama Index. So if you're already using Llama Index, you now have a managed service directly on the cloud. Let us start with RAG in general. For people who are not familiar with this domain or never heard about RAG, RAG means retrieval augmented generation. That's a mouthful of words, but in the end it's actually not too complicated. Without RAG, the large language model generates a response on the pre-trained knowledge. This might work for generic questions, but it fails, for example, for internal questions your company has or documents the model never has seen before. So let us assume I want to ask my large language model about my company's vacation policy. Since the model doesn't have this information, we need to somehow retrieve it from somewhere. This is what the R in RAG means, retrieve it. And if we don't retrieve it, the model in best case cannot answer my question, but in worst case, the model starts to hallucinate and is starting providing bad or wrong answers, and that would be even worse than not getting actually an answer. The A means we augment this data to our large language model and generate. So retrieval, augmented generation. That's what RAG is about. And with that, let us go into the RAG API and how this actually looks like. In the background, invisible to us, the Google's RAG API is doing quite a few steps. It creates a vector index for us. For all the documents which we can upload to this API, it's creating embeddings and storing them into the vector database. And then we can also use this index to retrieve relevant documents for a query we are sending to our RAG API. So if I'm asking about Duet's vacation policy, the company I work for, it now takes this question, it's sending it to the embedding API, to the index, and then I'm getting documents back where there is a similarity in the documents based on my question. And this is sent to a large language model. All right, and with that, let us directly go into the code. For today, I have prepared a few example documents because we want to do this on documents. I used Gemini to generate some dummy manuals for imaginary products. So we have this Pure coffee machine, we have this Aurora Glow LED lighting system, and we have a Nimbus cloud weather station. That's the data where we actually want to retrieve information. This isn't available in Gemini's knowledge because it's something which was generated out of nowhere. So if I'm asking Gemini, how can I attach the LED stripe to the wall, it cannot answer this because where's the information coming from? That's why we have these documents, and that's what we're gonna use today for this example. All right, directly to the code. Everything starts when we're using the RAG API. You see this is still a preview feature. That's probably good to mention. This is still a preview. So if you consider this running into a production environment, keep in mind this is preview. It might work well, but it could also fail at any point in time. Keep this in mind if you want to use this. Everything starts with a corpus. A corpus is a collection of documents we want to operate on. So first we need to define this corpus, and we do this by calling RAG create corpus. That's actually very easy to set up. And optionally, we can configure an embedding model. You see, we have this embedding model here. If you don't provide this parameter, it will use the latest one. Latest one is, as of recording this video or having this live stream here, it's 004. You're not limited to Google's embedding models. You can also use self-hosted embedding models by providing a Vertex AI endpoint. But you can also use a fine-tuned version of Google's embedding models. So you are fully flexible here, absolutely not limited to Google's embeddings. Anything which you're deploying to a Vertex AI endpoint can be used as an embedding model here. I think that's really great. So it keeps a little bit of this open source feeling of this tool. Then we need to have this corpus name. The corpus name is a reference for later on when we actually want to do something with this corpus. And in the next step, we upload documents to the corpus. In this case, I'm uploading those 3 documents, which we see here on the right side, so our manuals. And the RAG API takes all those documents, creates embeddings for each of those documents, and stores them again into the index. You can obviously also delete documents, you can update documents. So everything which you need to do if you have a real production use case, it's available via API and also via SDK. Upload is actually pretty easy. We call RAG, upload file, provide a corpus name, and provide a path. We do this for our 3 files, and then they're basically indexed immediately, and they're available for retrieval as the next step. But I also want to showcase you how you can index, this is from a local file system, right? I upload a file, that's why it's called upload file. But we can also import files. And import you can do from, this is actually, which you need to adapt. You can import files from a Google Cloud Storage location and from a Google Drive folder or Google Drive in general. So this is working out of the box from Google Drive and Google Cloud Storage. After those documents are uploaded, we can retrieve the corpus, see how many documents are actually in the corpus. And as the next step, we already do our retrieval. Retrieval meaning we send our question, and it's taking, as I said, this question and transforms it into an embedding, sends it to our RAG index, and then we are getting potentially good documents back, which are similar to this question. And from there, we can do something with it. We do that in the next step. But let me first go back, because if we're uploading files, you're probably interested on what kind of file types are actually supported. There's a full set of this. So let me go to the, open up the documentation for you. Those are the files which are supported. So you see we get Google Drawings, Google Slides, HTML files, JSON, Markdown, everything you see in this list. And here also see the file limits or the size limits for single files. So it's quite a few is supported. And this makes this very flexible, because you don't need to take care of processing those documents yourself. It's all managed by the RAG API. Just upload them, rest is done for you. Additionally, as I said, there are data sources. So we have cloud storage, we have Google Drive, but we have also Slack and Jira. And I assume there will be more coming. I could imagine Confluence, for example, or other services as well. One thing is important: when you are importing files, they are not automatically updated. So if you are importing a file from a Google Cloud Storage location and you update the file on a Google Cloud Storage bucket, they are not automatically synced. So you need to take care of this yourself. This is something where you need to consider an update strategy. Just keep that in mind if you do that. All right, quickly show you how you can use Jira. This is the code for Jira. So you configure your Jira server and you log in, and the projects or custom queries you want to use to import Jira. And then you have this Jira source and do import files with the source as Jira. Very similar for Slack as well. So we can open up Slack. You have Slack channels. You need an API key to import Slack. And then you import files, provide the source again, and you're getting Slack. You see how it works. So it's very easy to use, and it works really well out of the box. Let's go back to our retrieval. So the retrieving is done by actually, as I said, by providing those text, the query, to our corpus. And the RAG API will return those document chunks, which are most semantically similar to our question. You can configure the number of documents you want to get back. This is important if you have a small context size of your large language model, or you want to keep the context size small, or you want to keep it to the top 2 most relevant documents. You can configure this top K value. And you also have a distance threshold. Distance means the lower the distance threshold, the lower the distance value, the higher the similarity of the documents to your query. So you can configure this, and you cut out everything which is below, or in this case, above 0.5. And you kick it out, exactly. And from there, we now can take the documents which we're retrieving. We can actually give this a try, so you see how this looks like. Let's run this. The first time you're running this, it takes a few seconds, because now we are first creating the corpus. Corpus means also there's an index created in the background. And after the corpus is now created, and after that it's done, we are now uploading the documents to the index. So it takes a few seconds to process them. Let's wait. And the next step, then we take and augment and generate. We are going to augment and generate, so we are sending those documents we are retrieving back to Gemini, but you are absolutely not limited to Gemini. You could directly take the response from this retrieval step and pass it to wherever you want, right? You're not limited to Gemini at all. And now you're seeing, if you're scrolling down, based on our question we had, we are now getting this text chunk back. This is where our potential answer is contained in this piece, or this piece of chunk here. And you see we have a distance, which is actually not too bad, 0.3, that's good enough. It's below our threshold, so that's good. And here's important to know, you can configure the chunk size and also the chunk overlap. If you're uploading documents, or if you're importing documents, define a chunk size which fits to your use case. Sometimes a bigger chunk size is better, sometimes a smaller chunk size is better. It's something you need to play with. Also, the overlap is important, so you're not missing out on any of the information because it's cut off. This is a parameter you can apply yourself for the indexing step. All right, let's take it one step further, and now we are doing actually the augmentation and the generation. So we're taking our corpus. As I said, we need this corpus ID, and from there we use a retrieval tool. This is specific to Gemini. So Gemini has the capabilities to use tools. In this case, we're using our RAG API as a tool for doing this retrieval step. As I said, this is something you don't need to do. If you're using Anthropic or any other kind of open source model which doesn't have this tooling available, you still can use the output from the previous step, from your retrieval step, and pass it manually as a context to your model. What this thing is doing, it's just automatically getting the retrieved documents and passing it as a context to our model. That's basically just takes you away some of the effort which you need to do. You see we have the same parameters like before, but now it's combined. It's basically the same, but a deep integration into Gemini. We take Flash, and here we define our tool. This is how we use it. So in this final step, we are retrieving the documents and augment them with our large language model to generate an answer. Sounds maybe a little bit weird, so let me rephrase it maybe in an easier way. We send all the documents with our questions to the large language model. And the large language model is taking all the documents, using it to answer the question. This is also called grounding. So we are grounding our large language model on actual factual data. All right, let's run this. let's clear this one here. Back on Gemini. And you now see we are getting actually the answer from our large language model. You see we're getting, let me go to the question. I asked, how do I install the LED stripes? And then we are getting exactly what's in the manual from our large language model. So you see this is literally again done within 15 minutes, just a few lines of code. You upload the documents and you have your RAG available. Obviously there are some limitations because this is a quite managed environment. You don't have full control. For example, if you want to have full control, you always can build your own custom RAG. I have an article and a video on YouTube if you're interested in that. But this is obviously limited because you don't have full control over everything. You can do the chunking and you have control on how you use the response for augmenting, but that's it. Also important to know when you're uploading documents with this upload file method. So if you're going back, if you're uploading documents with upload file, you cannot provide a unique name. You see, this is you can define a corpus name, and if you check, there is a display name. But the display name, it's not unique. And this is something where I think there could be still a little bit more improvement because I want to have a unique ID for each document. Imagine I want to update this manual. First, I need to retrieve it, get the ID, and then maybe I can insert it or delete it and update it again. I wish there was an automatic or a unique ID which I can provide, but it's not there. Maybe it's coming at some point. So keep this in mind. Updating is a little bit more complicated, but it is handleable, right? Additionally, if you're using import files, it supports up to 25 documents here. So if you're considering uploading a large amount of documents, you need to do this in batches of 25. I actually haven't found any limitation in the documentation, but I tested it, and it's constantly stopping at 25. If I try to upload 26 documents, it's returning an error message. So there seems to be a limitation of 25 documents. I also see a few questions in the chat. I come to that when we are done with the session here. We also have a chunk size. As I mentioned, you can configure the chunk size if you want to. I also found in the documentation there's supposed to be an ingestion limit of 1,000 files. I'm not quite sure to what this 1,000 files is referring. I uploaded more than 1,000 files, so it's working. Maybe this is an old limitation. If someone has an idea, write me on LinkedIn. I would love to reproduce and see where this limitation is actually existing. From my understanding, there is no limitation of 1,000 files. All right, we have some questions in the chat. It's not possible to use Google's multimodal models for embedding. Exactly. So it's not, multimodal models are not supported here, so you cannot use it with an image because it doesn't support images when uploading. Only documents are supported, so everything which is text, so images are not supported. That's why also multimodal models are not supported. There's also a limitation on the to use one corpus. That's a good point. You only can use one corpus if you're going to the retrieval step. So retrieval query, you see, we can only actually we could use multiple corpuses here. So it's an array. I need to give this a try. That's a good point. You will, if you read my article, I will mention it there. I'm gonna do this after the live stream. So it could be that you could have multiple corpuses and use it for the retrieval because it's an array here. It's a list. So it should work with multiple corpuses as well. To give this a try. And also, someone is mentioning in the chat, if we are providing a dictionary, a directory, we can send more than 22 files. I'm going to give this a try. This is a good point. Also add this to the article. Very, very good questions in the chat here. Like it. Regarding the pricing, I am still confused regarding the pricing. So it's clear we're using Google's embedding API. That's something we need to pay when we're uploading the documents. We need to pay for the embeddings. We're also using the Google Gemini model in this example. So we are built by the number of tokens we are sending and by the number of tokens we are receiving. But I couldn't find any pricing for the RAG API itself. Maybe it's because it's still in preview and there is no pricing yet, or it's just very hidden. So I try to get more answers on that. So if you watch this video, check out my article. So it will be updated there if I get a pricing update. So as you saw, it's super fast. There is no need to set up a vector database yourself, like vector search or pgvector with Cloud SQL. However, it comes with a few limitations. Some of them we just saw, some of them we just circumvented or had found some workarounds. But I still believe that at least 80% of the use cases we have with RAG can be solved with this simple approach. If not, as I said, there are more offerings on Google Cloud. You can use Vertex AI grounding, which is another service, probably do another video on that as well. You can use this as some intermediate in between step, and you still have the options to build a fully advanced document retrieval architecture yourself. But as I said, for 90% of the use cases, or maybe even more, this will work. Someone is asking also here, why you're not using the Llama index API directly in the RAG API? It gives you more flexibility, but consider this is still a preview, right? They probably rolled this out pretty quickly. There was one big customer who had a need for that, and that's why they developed this integration. I believe there will be more features coming, and I hope at some point we will have the same feature set like we have when you're directly using the Llama index. For now, I think the biggest benefit is companies, they want to have everything within their cloud. And if you're using Llama Index, they also have their own offering where you're using basically their site, but it provides a third party again. So this is also for enterprises who want to use the Llama Index, but still want to have everything inside of Google. So if you're not limited there, you can use Llama Index directly. Still, I think this is a great service because it's fully managed. You don't need to take care of anything. All right, as you see, very easy to use. One final thing, I built a small UI around it. This will be also on GitHub, so if you want to give this a try on your own documents, you can provide your corpus ID here, and you can actually upload files to your corpus. So let me upload a corpus here. Articles, oh, sorry, GenAI. Let's go to the RUG API documents. We upload some dummy do-it company policies. Obviously, they are not full. It's just one sentence here about the vacation. It's now uploading. Takes a few seconds to upload. Now it's now uploaded, and I can ask, what's the vacation policy? We sent this. We're getting an answer. And the vacation policy at Do-It is actually unlimited vacation days. So you see, it's ingested pretty quickly, and we can directly use the index documents. So that's it for today. I will send all the links on either you follow me on LinkedIn or you follow my YouTube channel. I will upload this video on YouTube, and below the video there will be the link to the GitHub repository. Or you go to ml-engineer.dev and you scroll down. You have the the GitHub link directly at the bottom. It's called GenAI Livestream if you want to look this up. All right, see you next Friday. Maybe not. Maybe I'm on vacation next Friday. Let's see. We're gonna probably talk about either Cloud Run GPUs or context caching with Vertex AI. So see you next Friday.